The load path paradox. A stainless steel cylinder weighing over 100 metric tons just decelerated from orbital velocity to a dead stop between two mechanical claws. Unlike the Super Heavy booster, which is essentially a hollow fuel tank with engines, the Starship upper stage carries its primary payload at the top, creating a center of gravity that shifts violently as the header tanks deplete during the landing flip. Catching this vehicle requires the tower arms to absorb millions of joules of kinetic energy without crushing the thin 3mm steel skin. If the arms close a fraction of a second too early, they shear the catch pins, too late, and the ship performs a terminal litho-braking maneuver into the launch mount. This structural gamble is the only way to eliminate the massive landing gear, but it introduces the load path paradox, engineering the crush zone. To survive the catch, the ship requires internal longitudinal stringers that distribute the impact force across the entire airframe, rather than just the contact points. Engineers had to reinforce the midsection to prevent structural buckling, which ironically adds the very mass they tried to save by removing the legs. However, by utilizing the oxygen tank's internal pressure to provide rigidity, the ship acts like an aluminum can that is impossible to crush until it is empty. The math reveals that the internal pressure must be precisely calibrated to the deceleration rate provided by the Raptor engines. If the pressure drops too low, the ship crumples like paper upon contact. This delicate balance of internal pressure and external force leads directly to the problem of ceramic fragility. Ceramic fragility at zero velocity. The thermal protection system is the most unforgiving variable in the catch sequence. Starship is covered in 18,000 hexagonal ceramic tiles, designed to withstand the white-hot plasma of re-entry, but these tiles are notoriously brittle. When the chopstick arms make contact with the ship, they create high-frequency vibrations that can shatter the adhesive bonds of the surrounding tiles. Losing a single tile during the catch is acceptable for a prototype, but for a vehicle designed for rapid turnaround, it is a failure. The solution implemented in 2026 involves active damping in the tower arms, using hydraulic actuators that mirror the ship's oscillation in real time to minimize the shock. Think of it as a baseball fielder drawing their glove back to soften the catch of a 90-mile-per-hour fastball. This mechanical sympathy is the only thing protecting the heat shield from the precision margin. The precision margin. The guidance software must account for aerodynamic buffeting and local wind gusts that can move the tower several centimeters. The ship does not just hover, it executes a controlled fall with a millimeter-level precision window. The reaction control system fires nitrogen gas in microbursts to fight the ground effect turbulence created by its own engines. This is the precision margin, the signal under the noise. The successful catch of the Starship upper stage transforms the vehicle from a reusable rocket into a piece of orbital logistics infrastructure. By moving the landing hardware from the ship to the tower, SpaceX has effectively traded vehicle complexity for groundside stability, allowing for a payload capacity that competitors cannot match without doubling their rocket size. This shift proves that the goal was never just to save the engines, but to enable the rapid relaunch cycle required for orbital propellant transfer. If the tower can catch, inspect, and restack a ship in under 6 hours, the bottleneck for Mars missions shifts from manufacturing to simply waiting for the Earth to rotate. For engineers and strategists, this catch represents the death of the expendable mindset. We are moving toward a reality where spaceflight looks less like a high-stakes artillery launch and more like a high-volume rail yard. The next indicator to watch is the integration of the automated tile inspection sensors directly into the chopstick arms during the next flight cycle. Subscribe for more.